page 6. We have for questions 5 through 8, it says use this function. All right, f of x is equal to x over 3 plus 7. All right, so let me just get a new calculator on Desmos. All right, so it's asking us to evaluate that function for a few different values of x. But just a reminder, when we say f of x equals, we're saying that that's y equal to f of x. All right, so f of x is equal to some y value along the graph of x over 3 plus 7. All right, so when I say evaluate f of 6, I'm really saying take this function, all right, this function where y is equal to f of x, and just bearing in mind, and this is just a quick review of what we were talking about yesterday in terms of the notation, when I say y equals f of x equals x over 3 plus 7, I'm really saying that y is equal to x over 3 plus 7. I'm also saying f of x is equal to x over 3 plus 7. I'm also saying that y and f of x are the same. They're equal to one another. All right, so this triple equality here is really just the same as saying all three parts are equivalent to one another. So you could take any two pieces of this and make an equation out of it. All right, so when we want to find f of 6, I'll do it by hand first, then on Desmos. If we want to find f of 6, that's saying replace any x in your function with a 6. All right, because it's a function of x, but we're letting the value of x be equal to 6. And the result will be some value y. All right, now this is really the f of 6. Well, that would have looked nice, I guess, but this is really just a notation. It's a set of instructions. It's telling us what to look for. All right, f of 6 will result in 6 divided by 3, which is 2, plus 7, which is going to give you a result of 9. Oh, equals. So the y value is equal to 9 when the x value is equal to 6. So the y value is 9 when x is 6. Right? Or you could even think of this as an ordered pair, like 6 comma 9. All right, that's what I was getting at yesterday. It's really very similar to stuff. I mean, it's the same concept as what we've been working on all along, finding coordinates on a graph. It's just we're naming it something else. All right. So if you kind of look at it, and I'll just kind of jot it off on the side here, we would say x comma y is some coordinate, right? Some coordinate in space. You plot any coordinate using the x value, comma the y value. What I'm saying is, all right, let's just think of y as f of x. So another way to write that coordinate would be to say x comma f of x. All right, these two things are the same. All right, so it would be just the same as if we started off our studies involving coordinate. It was really called coordinate geometry, but you know, the idea of plotting points, and somebody said to you, all right, take your x value, which is the distance away from the y-axis, and they never said y, ever. They just said take your x value and the distance, which is the distance away from the y-axis, and your f of x value, which is the distance away from the x-axis, and plot those 2 points. All right. The f of x is being swapped in for the y value, with the added bonus of it giving us the indication that we're looking at a function. All right. So the graph itself is that of a function. Now on Desmos, that's the beautiful thing, and why we like Desmos. You type in your original function, and then you type in the expression that you're looking to evaluate. In this case, it's just a number. All right, f of 6 gives you a 9. All right, so you could follow the same process for question 6, or you could just type in f of -9. Oops, parentheses. Got to have the parentheses. Which would give you a result of 4. All right, so it's the same process. All right, but it's just a question of whether you want to do it the longer way or if you want to just do it by the number crunching way. All right, so number crunching as in just typing it into the calculator. Now, for 7, showing all necessary work, that's like a stock phrase that I use to say, all right, as long as you have some work that justifies your answer, it's going to be good, and that work could be a Desmos link, all right, as long as it has the right ingredients. Find the input for which f of x is equal to 13. Well, f of x, they told us here, f of x is equal to x over 3 plus 7. All right? So they're saying that that has to be equal to 13. The input is the x, the output is the y. Not always the case, but in the case of these types of functions it is. And, you know, in most functions that we'll be working with, but there are instances where that'll change. In the magnetic dart activity that happened. All right, but essentially we're looking to solve this equation. So you solve it any way that you'd like. If I'm doing it algebraically, I'm going to multiply everything by 3. So both sides. So I'll get x plus 21 is equal to 39. I'm going to knock off the 21. And in doing so, I'll get my solution. Well, the whole thing's a solution. I'll get my answer. My answer. X is equal to 18. All right, so I could do it that way. Or I could do it on Desmos. The Desmos approach, and I'll try to get this up on Schoology, but it's really not that hard to type in if you do it like along with me. Then you can save it and have it available. You know, that's just a thought. I mean, I try to do the demonstration, but and then save the Desmos up to Schoology, but sometimes I forget. But if you do it along with me, then you can just save your work as you go, all right? Because when you're taking a test, my hope is that you're not working off of blank slates when you're using a Desmos. You go into you go into this little menu here, and you go down. Okay, what do I got in my little repertoire here? You know, what do I have in my quote unquote notes? You know. Oh, by the way, there's my dart throw. That took a while. Look at all this code that I had to put in. Well, code is a relative term, but I had to put all this stuff in there, move some points around. It was fun, but the kind of fun that only a math teacher can have, I suppose. So anyway, if I want to evaluate a function, we already know that that's going to be easy. And so, like, let's say you want to do it right now. First thing I would do is maybe put in a little note saying that this is to evaluate a function. All right. Then I would say, type in your function, something like that. Some little reminder to myself of what to do. All right. And then, I'll put in some function, because I want to have something as a placeholder. In this case, I put the f of x is equal to x over 3 plus 7. So I have my function in there. I could do a little zoom in if I want, just to make it look a little nicer. All right. Now, if I want to evaluate that function, all right, I might put a little reminder to myself. All right, what x value am I using to evaluate my function? What is my f of, what is the number I'm putting in? F of what? So some sort of reminder of that. But what I would do probably is just put in something like f of n for number. And create a slider for that. But you could jazz that up any way you want, where n is the number in the problem. Let n be the number from the question. And so going back to number 5, all I'd have to do is slide my slider over to the number 6, and it would give me my answer, which was 9. I'd slide my slider to -9, which would give me my answer of 4. And then if I had something that was kind of weird, like a decimal or maybe something not restricted between -10 and 10, I would just tap on the number here and just type it in. So let's say I needed to find f of like 2.1. Type in, the 2.1, and it'll give you your answer. All right. But, that's not necessary for this case, but there you go. Now, going the other way, where it says find, showing all necessary work, find the input for which f of x is equal to 13. I'm just looking for really the reverse, where f of n, that result is equal to 13. So I would just slide my slider until that number became a 13. All right. And if it goes off the grid here, if I go to the end of the slide bar and I'm not quite high enough, I could just tap on the end. I just tapped on that 10. You get the -10 and the 10, the little bounds. Just tap on one of them and just make it bigger. Make it like 20. And then keep going. I'm trying to get to a 13, and it looks like that happens right here at the n value of 18. All right. So what this is telling me is that f of the n value of 18 will give me 13. It's just direct substitution. All right. So this line here, I'll actually just snip it and bring it in just so you can see the direct relationship. People get hung up on the notation, but it's really a whole lot easier than it might seem, at least initially. So let me just put it in here. All right. The question is saying f of x is equal to 13. All right. Right here it's saying f of x is equal to 13. What we just showed is that f of n, based off of these computations, f of n is equal to 13 when n is equal to 18, which meaning f of 18 is equal to 13. Which answers the question, because if I just do a quick comparison between what they're asking and what I just stated, the only thing different between what they're asking and what I just stated was that they had an x and I have an 18, which means x has to be 18. Now, we came up with that algebraically, but this could be sufficient work on a test. All you'd have to do is save this. You got to save it and then submit it. All right. So those problems should get easier and easier as you go. It takes a little getting used to, but they get easier. But number 8, that's just a crazy looking expression. 2 f of x minus 1. It's like, you didn't teach us this. Yeah, but if we know that f of x is equal to x over 3 plus 7, because that's what they set up here. F of x is equal to x over 3 plus 7, and they said that applies for the questions 5 through 8, and this is question 8, then it's really just a matter of substituting. All right, so when we substitute, we use the distributive property. We get 2x over 3 plus 14 minus 1, which would be 2x over 3 plus 13, and that would be my g of x. All right, now one thing we did gloss over yesterday is the idea that we could name functions as something other than f of x. All right, so the idea is that if f of x represents notation, all right, then what if you have multiple functions that you're working with at the same time? And you'd have to have some way of distinguishing one from the other. So we start with f of x, and if I have another function, we call it g of x, then h of x, and we work down the alphabet from there. All right. So g of x is another function of x, just called by a different letter. All right. Now, it's kind of surprising, but Desmos can handle this too. All right. So if I type in, I don't want to lose this, but if I type in the two separate functions, f of x and g of x, f of x and then g of x as a function of f of x. Actually, I think I could type it in because I already have f of x in here. I'll just have to delete it before I save this for you. But I could type in g of x equals 2 times f of x minus 1. And what it'll do is it'll create the graph of that function, that new function. All right? The problem is it doesn't tell you what the equation is of that function. It won't give you the 2x over 3 plus 13, but it will give you the y-intercept just by tapping, and you can see the y-intercept of that is 13, just like the y-intercept of the equation that we just came up with is 13. All right, so being able to identify slopes and y-intercepts would be enough to get you to at least verify part of this. All right. So this one's a little bit of a trickier situation because it's all strictly based off knowledge of the notation, but again, you get used to it. Number 9, just a crazy looking problem because you're given a graph. But if you understand that anytime you see f of anything, it's asking you for the y value that corresponds with the given x. So each one of these values are inputs. All right, each one of these are input values. All right, and then each one of the results are your outputs. Now on a graph, the inputs are your x and your outputs are your y's. If you make that recognition, then all you're really coming up with is, okay, I have an x value of -7. What y value corresponds with that? All right, so I'd go to my graph here. It helps to number it, or at least I think it does. At least the x values. When you have multiple problems, because otherwise you're counting boxes repeatedly and it's just a pain. I mean, just doing it the once as opposed to counting the boxes repeatedly. I don't know. You be the judge. I'm not going to force you to do that, but I find it to be helpful. Because now when I look at -7, I see that there's a point right here. Now I'll count boxes as 1, 2, 3, 4, 5, 6 units down. So -6. The y value corresponding with that x value is -6. At 4, I'm 1 unit up. The y value corresponding with that x value is a 1. At 0, I'm 3 units up. The y value corresponding with the x value of 0 is equal to 3. And at 9, I am 1, 2, 3, 4 units down, so -4. All right. I find that to be a helpful strategy, but it's not always the case. Some people look at that and say, I'd rather just count the boxes than label. But that being said, I mean, if you're working off a computer screen, you're not labeling anything. You're counting boxes, and it is what it is. If you have a hard copy, it's a different story, or one of these. So for how many values of x does f of x equal 5? So the input is unknown. The output is known to be 5. So the y value is 5. So at the y value, I'll use a different color. I'll use something a little brighter. Use this color. 1, 2, 3, 4, 5. So here, that's a little too bright. Jeez. I'll go with this one. All right, so 1, 2, 3, 4, 5 units up. That's the y value of 5. I need any x value that corresponds with that. All right, so anything on this level here, this y level, or this horizontal line of y, would be part of my solution. All right, so it looks like I have a point here, a point here, and a point here. That last one's a little iffy. I can't really tell. It doesn't look like it's quite on that -10. But it's really asking us how many anyway. But if I had to state it, I probably wouldn't say -10. I'd probably say like approximately -10. But here it's saying how many. So there's only 3 values. And then the last bit doesn't really have anything to do with evaluating functions. It has to do with interval notation and domain and range. Just a little review of that. So the domain, all possible values of x. The range, all possible values of y. All right. Now, this is kind of, I'm not in love with, actually, honestly, I'm going to toss this question for this graph because you wouldn't have known going in that you're supposed to know that this graph extends on forever. It makes it seem like it comes to a complete stop because it's cut off. You would think that there were endpoints here, but the way the question is designed, it's implied that it goes on forever. So it's depending on how you interpret it, you get 2 completely different answers. All right. So if you were to say, assume that the graph comes to a complete stop, you'd say -10 to 10 for x, and you would say -1, 2, 3, 4, -6 to like 5 and actually -6 to 6 for the y's, but it's really supposed to be -infinity to infinity for x and -6 to infinity for y. But there's no way you would have pulled that without making an assumption. All right, so it's a bad question. I'll take it as a typo. All right. So then there's a lot of repeats on the next page, except this time there's a lot of references to g of x, which now you probably have a lot more basis to understand, but let's do number 1 together at least. All right, it says let f of x equal 6x minus 3, and let g of x equal that lovely looking expression. All right, but it's an exponential expression, but nothing we can't handle. Just seems like it would be something we can't handle, but it's not that bad, because if you're evaluating a function and you know g of x is just another name for a function, then it does the same thing. All right? It just means that you're going to take whatever the function is and replace the variable with whatever you're evaluating in terms of. So this is some value y equals f of 0, just like the original function is y equals f of x equals 6x minus 3. So your result is going to be some value of y, in this case -3. All right, so you're just plugging and chugging away. You could use the slider approach just by typing in the f of x, 6x minus 3, at 0. So I'd slide my slider to 0 and see what I get. I get a negative 3. So we're good. All right. Or you can just type it in if you want. Now, the next one has a g of x. So I could just pop that in here. So 0.5 times 4 to the x power. And this is happening at the value of negative 1. But if we're doing it by hand, same deal as before, 0.5 times 4, but now it's raised to the negative first power. All right. So we just plug and chug that away. G of negative 1, we get 0.125. Put that in fraction form, you get 1/8. So y equals some, or g of x equals some value y, which in turn is equal to 1/8. Now, we haven't reviewed or really talked too much about negative exponents, so I don't have any expectation that you would do that one by hand. That would be technology, all right? We'll get to it, but at this point, it's like just pop it into a calculator. Negative exponent, okay, calculator can handle it, gives an answer, we're good, all right? But then you have f of 1 plus g of 2, all right? So I actually have my f function and my g function stored in here. So I can actually type in f of 1 plus g of 2, because Desmos is going to refer to the correct functions in order to come up with those results. F of 1, g of 2 results in 11. You don't really have to show any work because Desmos understands the notation. Actually understands it better than we do because it's programmed to understand the notation. It's almost like its entire life was designed around the notation. Its entire existence is DNA. So there's no way it wouldn't understand the notation, right? It's us that we have to make the adjustment, all right? So if you have f of x and g of x properly typed in to Desmos, then whatever you do notation-wise is going to be correctly interpreted, all right? Now, the rest of the problems here are just repeats of the same kind of problems that we've already talked about. Same idea with number 6 at the bottom. It's just a bad question. I mean, the question itself is fine. It's just the way the graph is presented is not good. So yeah, if you want to give these another shot, that's fine. But you can also, or you should also, continue to work through page 9 in the packet, which is just more review of domain and range with shockingly actually proper graphs. All right, so with some open circles and some fun stuff there. So yeah, that's where I'm going to leave it in terms of instruction. So you have the remainder of the period to work on that stuff.